implemented as asm.js.
All right, I think we're on to the next one here. Sage, this is your Newstore discussion, the new backend for the OSD. So go ahead and take it away. I think we're down to about 20 minutes.
Okay. All right. So this is motivated by, many years now of hacking on file store and cramming a bunch of stuff in it, and sort of realizing that it's at a point where it's very hard to modify and is far from optimal. So the goal here is to create a new implementation of our internal object store interface that would replace object store optionally, whenever it's that you can still have different backends. So it'd be general purpose, and so it would work on hard drives and SSDs, or some combination of the two. And the main goals would be to avoid double writes for new objects and sequential writes. So for all those use cases, we get rid of all the journaling overhead that we currently have now. Hopefully do something much more efficient with small writes, so we can avoid the fsync double write stuff that we're doing now, and like random inode touching and all that. And then I think that the main thing is that the main realization is that what we try to do now is sort of map our object names onto file names, and the fact that we have transactions onto sort of transactionally updating a POSIX file system, and that's just like a losing battle and a total disaster. It doesn't really perform well. So instead, we'll use the key value database for what it's good at, which is transactions and key value data and all our namespace stuff, and we'll use the POSIX file system that's sitting underneath for what it's good at, which is block management. So there's a work in progress branch that's linked in the blueprint. It's sort of working right now. You can do like reads and writes and attributes. OMAP isn't implemented yet. That's probably going to happen last. It has most of the infrastructure right now, except that right now, when you submit a transaction, a lot of the work is done synchronously. I haven't sort of split it off into a asynchronous completion thread stuff yet. But the basic machinery is there. So anybody who's interested in this should look at it. And possibly if you're looking at creating sort of a new backend, this might be a good thing to look at. I know a bunch of people are looking at using the key value store and layering that on top of a key value database. I think this is going to be simpler for a lot of workloads, and it might make for an interesting counterpoint, I guess, to whatever you're building. So just FYI. So I guess the current, let's see, what should I talk about? So the basic idea is that when a write comes in, if it is a new object or if it's an append to an existing object, then we just open a file, or open the existing file, or create a new file, and just write out the data and append to it. And then in order to commit the transaction, we'll fsync that, and then we'll, as soon as the fsync completes, we'll commit a transaction to the key value database that says, the size is now new, or the object now exists, and at that point the write is complete. And that currently works, and that works for appends and for creates. The file that it creates is like a really simple file name, but as short as possible. It's just a fresh inode, and all the mapping to get to that file happens in the level-db thing. So we minimize path traversals on the read side. It also caches the inode number in the key value database. So eventually we'll actually be able to use the open by handle interface. Actually, that isn't implemented yet, and we're actually not doing it quite right. But the idea is then if you're on XFS, or actually any file system, for example, you give the kernel a handle to open the file by the inode number, basically, or the handle, instead of traversing the file name path, which will speed it up a little bit. So that I think should be pretty good. The other thing that is implemented now is a basic write-ahead log. So there are cases where you can't just do an append. For example, if you're overwriting some bytes within the file, or if you're deleting the file, you have to commit the transaction to the key value store and then go back and delete the file sort of after the fact. And so there's a generic write-ahead log thing, basically, where when we commit the transaction, we also commit that there's this pending operation that needs to happen later, and then asynchronously that'll happen and get cleaned up. So that basic machinery is there too. And I don't know. It seems to be looking good so far. Any questions so far?
Yeah.
Uh-huh.
Is that true that we put journal scenes after the transaction compared to Fastdoor now? And I think it may increase latency before Fastdoor, and because although the transaction now almost are async OP, and it won't block, but I don't think it can be ignored, and it may increase latency than before.
Sorry, which part is the fact that the transaction is being done synchronously? Is that what you said?
Yeah.
Yeah. So that's currently the case in the code that's posted, but that isn't sort of the goal. So eventually, so right now it's synchronously actually doing the transaction, blocking in queue transactions. What it's going to do is actually just queue the transaction to hand it to the key value store, and then a different thread when that commit will trigger the completion. I just haven't done that part yet because I think that I wasn't sure what call to make.
Yeah. I want to know the actual reason about why we put journal scenes after the transaction. Why not we follow the Fastdoor character implement, and we can do some do some jobs before journal, such as we can skip journal if we meet some conditions. I mean that we can do some simple jobs before journal scenes, and we can put actual transactions after the journal scenes.
I'm not quite sure I followed that. So you're saying that start with the current file store and just skip the journaling step in certain situations? Or do you mean that you want to queue the work asynchronously in the Newstore so that the work doesn't happen so you minimize the synchronous work?
Yeah. Because just you mean that we need to get OID into transactions, and it may hit a block because it is.
Yeah. So that's true. So I think the assumption is that if you're ever submitting a write on an object, the OSD has already just statted the object and read it, so it should be in the cache. So that's the first assumption. So we should never block on the get onode piece. It'll already be there. The other thing I'm kind of trying to do is put as much stuff sort of in the synchronous queue transaction as we can, because the problem that we're seeing on the high performance, like on the SSD flash stuff, is that if we keep switching thread context all the time, then it just sort of falls apart. So my general thought is that the first implementation will just sort of put all the things that we expect not to block in queue transaction directly. If we find that that's a problem, then we can have an option where it sort of pushes that off onto, it queues it up and then something else does it. Maybe for slower disks, that'll work better. But I'm kind of guessing that if we're sort of careful about that, it'll work okay for disks too. But I'm not sure. Yeah. I'm not totally sure. So I mean, the main example is if we're gonna queue right to the file. If we're doing buffered I/O, usually that's not going to block, and so we can just do it synchronously. If we're doing direct I/O, then we can start an AIO operation, and that also generally won't block, and so that can be done synchronously. If it does block, it's because there's memory cache pressure, and we need to slow down anyway. And that's the same case where the current stuff we have in file store, where it does all the throttling, where that would be slowing us down. And so I think we can just sort of skip all that complexity and just let the kernel back pressure do that for us. That makes sense?
Yeah. I know your meaning, but I don't think the write or read the kernel interface, this job can be ignored. And in a faster SSD, I think it can compare to the original director in file journal. So I still have very, very, very concerned for the latency.
Mm-hmm.
Yeah.
Okay.
Yeah, Sage, one thing. So regarding this this queue transaction one, right? So I can share my findings. So right now with the key value store, I removed this thread pool stuff that is actually asynchronously submitting the transaction. So that instantly giving me actually 3x performance benefit. Just actually OSD threads carrying out transaction, it's giving 3x performance benefit if it's from the SSD. So yeah, not sure about that hard disk, how much actually it will be bringing. So another question is that, so are you actually committing the transaction when it is, means at what stage actually you are committing this transaction?
Yes. So it's confusing because the current code that's posted does it synchronously in queue transaction. It actually commits it to, but that's not what it's actually going to do. It's gonna queue the transaction and return, and then we'll have a callback or something that will wake up. I wasn't sure exactly how the key value DB interface for that currently works or how it needs to be changed. It kind of looked, I don't know, I just wasn't worrying about it yet. But the current plan would be that it would queue it, and then when it commits, then the second set of callbacks would trigger.
A lot of noise. So basically, you are planning to commit the transaction after actual write here, right? So actual write to the file system, right?
Yes, yeah. So in general, right, you do all the I/O, you queue up an fsync, and when that fsync completed, then it would do the commit to the key value store.
Yeah, so that may actually hit you back for the smaller writes, maybe.
That might what?
So basically, that might hit you back for the smaller writes. So
yes. So for smaller writes, it's different. So and what's currently written and sort of what I've currently described is handles sort of the appends and the small overwrites where we do the write ahead logging. There's sort of a second idea that that we were discussing, and the idea there is that if you have small overwrites, instead of going through all the overhead of doing a write ahead transaction and then after you commit it, writing it in the background, we should just store those small writes in the key value store also, and just have some bound on the number of like small extents that we're storing in the key value database. So maybe once we hit like 10 extents, 10 random 4K IOs that we're storing in the key value database, we would say, okay, fine, now let's go take them all together and we'll update the file in the background. But it would sort of batch them, and so that you would do them all at once.
Yeah, somebody has to stage it somewhere.
Sorry?
Yeah, so somebody has to stage it somewhere.
Somebody has to scale it?
Stage this small write.
Stage it, yes.
Single one.
Yeah. So the thought would be that like right now, all the key names for the O nodes are like O underscore and then the object name, and the all the inline data, I guess, these small extents that we're storing directly in the key value database would be stored under a different prefix, so that they would not sort of pollute the part of the key value namespace where we want to have the right cache affinity or whatever. And so all the extents for a single object will be stored next to each other, but sort of not next to the O node. But in the O node, we would have a count of how many extent those are and maybe what their offsets are, so we can just fetch those keys directly. And then once we hit like 10 or something, we would say we just fire off some random asynchronous background thread that would go read them up and then write them to the file. And then once the file is f-synced in the background, then we could delete them.
Yeah, since you are doing this f-sync and using this buffered IO, I think XFS will actually will help you here on that on aggregating these smaller writes, because that's what we are seeing, that key value store versus this file store implementation. So even if there is a 2x
small write,
2x write amp, but this write per second that IOStat is reporting is much less in case of file store than this key value store, because since we are doing a buffered stuff, right? So I think they are actually XFS is simulating this.
Yeah. So right. So So there are a couple things that I'm hoping will work. So one is that a lot of the stuff that we're putting into the key value database, where we're kind of assuming a log structured merge tree like RocksDB or LevelDB. A lot of the stuff that we're sort of streaming out to the RocksDB log is either the O nodes that eventually, yes, will get condensed and compacted on the back end, and that's fine, or it's going to be the write-ahead log items, which are going to be short-lived and are going to be deleted by the time any compaction happens, and so they'll never end up in an SSD table, or hopefully very rarely. And then also the inline data items will be the last thing. And for those ones, they will sort of end up getting compacted, but they'll all be sort of on their own separate part of the namespace. And the hope there is that, say we do 10 random IOs, they're all sequential in the log, so they're very cheap. And it's a write that we already had to do to update the O node. So the write application, sort of the immediate write is a single IO essentially for that small IO, because the O node and the small data are right next to each other effectively in the LSMs, the key value stores journal. And then later when we do the second write to the object, we'll have a bunch of them that we'll do at once. So hopefully we can exploit the locality on the disk. There will be only one inode update in XFS if there is one. If we're lucky, we'll be able to tweak XFS so that it doesn't update mtime. That would be, apparently there's an ioctl. If you call the XFS ioctl instead of the open by handle generic syscall, there's a flag apparently that you can pass to it that skips mtime updates. So we can sort of avoid, as long as the file is already allocated, we can avoid any extra XFS overhead. Hopefully, it would just be an IO to the actual allocated space, I think. So I'm hoping that a combination of all those things will end up with like a pretty decent picture, both for the small IOs, where instead of having 2x write amplification, you'll have 1.1 if we're doing it 10 extents inline or something like that. Plus the I guess you also have the amplification that happens in the key value database too. You can't ignore that. Yeah. But it'll be better, at least than what we're doing. I'm pretty sure it's going to be strictly better than what the file store is doing.
Yeah. I have another. Yeah. Oh, sorry.
Sorry, please go ahead.
No, go ahead.
Yeah, I have another question. That is that true that we will issue a sync F?
Sorry, your audio cut out right after you said fsync.
Yeah, I mean, I read the blueprint and found that you mentioned that we will issue a sync fsync OP or fsync call to local fast system for each transactions to issue the durable of transactions. Yeah.
Yeah, I mean, we have to. Yeah, so that's the idea. I mean, we have to fsync it at some point. Yeah.
But I think we have some advantage before because we delay the write back and for some hot use case it may good. Yeah, it may good for batch write. For example, we may write lots of write to only small objects, and we can batch write this object in one fsync. And now we may issue fsync each time, and it may increase more write to disk.
Yeah. So it's true. It might be that the doing a big syncfs at a large granularity is going to schedule the IOs better than doing all these fsyncs. On the other hand, it might be that the fact that the new journal is effectively just a file that's the key value databases log. The fact that it's not pre-allocated means that XFS sort of has the freedom that it has all these small things that it's writing. It could, if the allocator's smart, it can just actually lay them out sequentially, and combine so to actually you have a pretty good IO pattern on disk. I'm hoping it ends up being reasonably smart. And if XFS doesn't, I think ButterFS certainly is really good about laying out lots of IOs sort of sequentially as it lays them out on disk. But hopefully that will help. The other thing that we have going for us is that if you issue lots of fsyncs in parallel, then in parallel threads, or if you use the AI, well, not if you use AIO, but maybe if Dave Chinner's patch goes into XFS, then XFS can batch those up and also make its internal journaling a little bit more efficient. Maybe that isn't so helpful in this case, but yeah, I don't know. I mean, we'll see. Right. So at a high level, the goal is to get this in a usable state as quickly as possible. So the main gap is that I need to make OMAP work, and need to change the current transaction submit so that it's not synchronous, that it's actually doing it asynchronously, so that it isn't super slow. But once we do that, I think it'll be in a state where we can actually start benchmarking it with different workloads, right? So we can focus on just giving it a bunch of sequential IO and see if it will effectively, use up all the disk bandwidth. Actually get, 80-90% of what the disk can do out of the drive instead of 50% or less that we do now. Then we can throw, small IOs at it. Make sure the write ahead logging look at the IO patterns that it's generating and see if that makes sense, or whether we should do the inline data thing in the key value database, and then whatever. Yeah. So basically, I wanted to get it to a state where we can experiment and actually see how it does soon, so that we have lots of time to sort of adjust the strategy based on what we find.
Hey Sage, a while ago, we talked a little bit about trying to simulate the kind of workload that would be happening inside the LMDB or RocksDB or whatever. Did you ever take a look at any of that, or?
No.
Is that still worth doing, you think?
It depends on what you're talking about. Are you talking about the file store workload generator thing, or do you mean something, or you're talking about something that was key value specific?
Well, I guess I was specifically thinking, is there any good way for us to tell with the new work that's going on what kind of store might make sense, or is there any, yeah.
I think we can sort of hypothesize what's going to work best and then just try it, right? So we'll try LevelDB, we'll try RocksDB. We'll most likely find that RocksDB is better than LevelDB, I'm guessing, but I'm not sure. Maybe that's different on disks versus SSDs. We can try LMDB, which we're going to talk about, I think, in a moment. I'm curious how that works, but yeah, we'll see.
One of the things I'd like to be able to tell is like how much better, say, like universal compaction is in RocksDB versus actually using like leveled compaction, and if we see like high, latency spikes or anything else like that. Yeah,
definitely. So there's a question from Barada in the IRC channel. Can't we use ODirect and OSync on the back end instead of fsync? Definitely. So I think the goal is to do either one or the other, and I think we would decide based on whether we have a hint that we don't want to cache. So if the don't cache hint is set, or maybe if it's just really big, we can sort of assume that it's sequential and we don't need to cache it as much, and then we can do ODirect OSync. And if not, then we can do buffered IO and actually explicitly call async. I think it doesn't matter that much, because specifying the OSync flag on the file handle is effectively just means that after you do the write, it does the same thing that fsync does, or fdatasync. So it's not all that different. The amount of work that the file system has to do is the same. Like, it still has to update the inode. It still has to make sure that the bytes actually get flushed out to disk. But yeah, we'll have to be careful. Okay. Any other questions?
I'm not sure. Do you see my BP about checkpoint method for sync thread like for Faststore or for Newstore? Do you consider this method for sync just like database? What database carry do? Like MySQL, it use checkpoint method to flash the in-flight object, which is in general but not in a disk.
I mean, that's effectively what the file store is doing, right?
Yeah. But it may optimize the Faststore things because Faststore only always sync all objects and because it has a sync thread during each 5 seconds or more.
Mm-hmm.
Yeah.
So your suggestion is to do something like that in the Newstore or key value store too?
I mainly maybe we can optimize the readback method for Newstore or for Faststore. Mm-hmm. It both okay.
Mm-hmm.
Yeah.
So the current thing that in for large IOs or appends, large appends at least, we want to just avoid any write back. It should just do it. So we avoid the double writes completely. But so ignoring that, if we're talking about small IOs, then we have this write ahead log. Right now, the basic thing is just as soon as the transaction commits, it'll in the background it'll just go and do the write ahead log. But we could definitely like try to batch that work up or delay it for as long as possible so that we sort of are doing aggregating multiple writes to the same object, for example, and so forth. I think that would definitely be something we could experiment with. I'm not sure if like a full checkpoint type scheme makes sense because they're sort of we're doing different things for different objects. So there's no longer sort of a global view of a global journal and a global consistency point and that you're rolling forward from. Right? It's sort of separating this into individual PG streams effectively that are being done independently.
Yeah.
So Sage, one question regarding like when you don't have this this write-ahead journaling, like say append and all, right? So you have to make sure that data goes to the disk before you actually acknowledging back, right? So you, in that case, you cannot use this buffered IO, right? So you have to use this ODirect and OSync.
If you would either do ODirect OSync as an AIO, and when the AIO completion happens, commit it to the database, to the key value database, or you would do buffered IO and do an asynchronous fsync, and when the fsync completes, it would commit to the database. But either way, you start the IO, and when it actually hits disk, then you update the database and then ACK it back to the client. So it's sort of the same. It just depends on whether you're going through the page cache or you're skipping the page cache. But in both cases, you start the IO, you wait for it to commit, update the database, and acknowledge it. Yeah. Okay, so we're a little bit over. Should we switch gears and talk about the LMDB stuff? Are you guys here?
Sure.
It's Sean and Jinjin.
Yeah, let me get that switched over and we'll get started on that.
Okay.